factoring a binomial by decomposition. So the reason I've specified a binomial means there's only two terms. So there's two values and they're either separated by a plus or a minus sign. So there's two. Normally when we do factoring of decomposition, we're working with three terms, okay? And it's in what they call the standard form. So I'm going to rearrange this one just a little. We'll move it to the left here or rearrange the equation. Usually we put the x squared first and then plus 3x. And we'll set it equal to 0 on this side. And if you remember, standard form is y is equal to ax squared plus bx plus c. So we have an a, we have a b, and what on earth is our c? So our a value is whatever number is here, and that's the 1. So we got that. Our b value is the 3, but our c value, there's nothing there. So what number represents nothing?
0.
0. Okay. So I'm going to show you after. The easiest way to do this is to common factor. But maybe you don't see that. Doesn't mean we can't still use the method we normally use. When doing decomposition, we want two numbers that are going to multiply to whatever a times c is, and then they're going to add to our b term. Let me just see something here. I need to think of it. Oh, sorry, I accidentally erased the c there. We need two terms that multiply to the a times c and they add to the b. Well, in our case, the a term is 1 and the c term is 0. So a times c is it's just 0, right? And then the b term, well, the b term is 3. It's our number 3. So this is a little tricky. Normally when we go through this, we look at factors of this number, but the factors of 0 are infinite. One of the numbers is going to be 0. That's for sure. Okay, one number will be 0. But I can multiply 0 by any number, so this is like an infinite number of solutions here. So this is the rare occasion where we actually go to the addition. Now, we use a little deductive reasoning, they'll call it. We know one of these numbers has to be 0, which means one of these numbers has to be 0 in adding. Well, that actually narrows it down a lot for us. If we're adding a number to 0 to make 3, what's the only number we can add to 0 to make 3?
3.
3. Okay. So now we know what the two values are going to be, 0 and 3. And okay, 0 times 3, that works out great. That's 0. So now we do our decomposition. Let's do it. I don't know if to do it in a special way, but we would split this term here, right? We would split this term here. And we would get, and I'm going to purposely put the 0 on the left side just to make it a little harder of one to work with. So we have 0x, okay, plus 3x, and then we still have that plus 0, okay? And now we look for common factors. Do you recall doing this at all? Where we kind of look for a common factor in the first two and then a common factor in the second two here? Okay.
Sort of.
Sort of. Okay. Well, we're going to common factor the first one here. And the first one here, we're left with, if you look, 0x is a common factor. We can take x out, okay? So let's common factor out our x value. Okay, so that means we're going to divide both of these by x, and that becomes the common term. So we have x on the outside of the brackets. And x squared divided by x is just x. 0x divided by x is just 0. So we're going to add 0 here, okay? Now, and the second bracket is a little trickier, okay? A common factor here. Okay, we need a common factor. Well, I can really divide 0 by anything and it'll stay as 0. This is where the trick is. I'm going to divide by whatever the term is in front of the x. So I'm going to divide by my, my 3 value. Okay, I'm going to divide both by 3. Nothing's going to change here because I can actually take out an infinite number of values out of x. I just want to get rid of what the coefficient is here. So 3 will become our common factor, or positive 3. Okay, and 3x divided by 3, well, those cancel out and you're left with just x. Okay, and 0 divided by 3 is just 0. Okay, and now if you remember, these two brackets are the same, so we common factor those out. Okay, x plus 0. And then in the other bracket, we write whatever's left over. Is this seeming familiar a bit?
No.
No? Okay, that's all right. We'll go through it again with a different example. And we have it now. This is our factor form. But I don't need to put plus 0, because 0 doesn't do anything. I can just have x times x plus 3. Now, this is considered a very, very long about way of doing this, because if you really remember, I'm going to write the original one over here again. It was x squared plus 3x is equal to 0. If I had just common factored x out from the very, very beginning, I'd be left with x, and then I'd be left with x plus 3 equals 0. So to do it through decomposition is just tiresome, right? Make an upside down face. Ugh, so much work to do it that way. It's so much easier if we just do a common factor. But it can be done, it's just a little trickier. There's a lot more mathematical thinking going on. So it's easier if we can just recall that we can factor it by factoring rather than decomposition. I'm going through it.